In aviation, some dangers are just obvious, right? Like thunderstorms. You can see them coming from miles away. But one of the most dangerous threats is one you might not see at all. Today, we're going to break down aircraft icing, a quiet, sneaky, and incredibly dangerous enemy in the sky. Let's get right into it.
So, why is a tiny bit of ice such a huge deal? And you might think it's all about the weight, but that's not the main problem, at least not at first. It's about how ice attacks the fundamental physics of flight. It literally sabotages the very things that keep an airplane flying.
And that is what makes this so incredibly scary. See, we're not talking about some big, obvious icicle hanging off the wing. The most dangerous icing can start as just a thin, rough layer, almost like frost, that a pilot could easily miss on a walk-around. But its effect is anything but small.
And get this, just a thin layer of frost, something you could barely feel, like coarse sandpaper. That alone can jack up the aerodynamic drag, that's the force holding the plane back, by a staggering 40%. And at the exact same time the drag is shooting up, something else is plummeting. That same barely there layer of ice can slash the wing's ability to generate lift by up to 30%. So you've got more drag, less lift. That is a textbook recipe for disaster.
Okay, so what does it take to create this kind of danger? What's the perfect storm of conditions we're looking for? Well, you might be surprised at just how simple the recipe actually is.
Seriously, it boils down to just two things. First, you need visible moisture. For a pilot, that just means flying through clouds, fog, or any kind of precipitation. And second, the skin of the aircraft has to be at or below 0 degrees Celsius. That's it. Super simple and super common, especially if you're flying in Canada.
Okay, but here's where it gets really interesting. A bit of a curveball. The plane can literally make its own ice. As air rushes over the curved top of a wing, it speeds up, its pressure drops, and so does its temperature. It's called aerodynamic cooling, and it means ice can start building up even when the air outside is actually a few degrees above freezing. Sneaky, right? Right, so not all ice is the same. Pilots have to know what they're looking at, because there are three main types of structural icing. And each one is its own unique kind of problem. Let's dig in.
All right, so you've got rime ice. That's the milky white stuff that forms when tiny little water droplets freeze instantly. It's a killer for smooth airflow. Then there's clear ice, or glaze ice. This stuff forms when bigger drops hit the wing and kind of spread out before they freeze, creating this solid, heavy, and, clear sheet of ice. And mixed ice? You guessed it. It's the worst of both worlds, a nasty combination of the two.
And that brings us to why clear ice is really the one that gives pilots nightmares. You can't see it easily, it totally messes with the shape of the wing, and man, it gets heavy, fast. It's just a stealthy, heavy, stubborn enemy.
And then you have the absolute supervillain of aircraft icing, supercooled large droplets, or SLDs. These are water droplets that are technically below freezing, but they're still liquid. So when they smack into a wing, they don't freeze on contact. No, they flow back behind the heated parts of the wing, the de-icing equipment, and then they freeze. This creates a ridge of ice in a spot the plane literally has no way to defend against.
So we've talked a lot about the wings, but the danger isn't just on the outside. Ice can be forming where you have zero visibility, right inside the engine, basically choking it.
Imagine this. You're in the cockpit, everything looks good. The wings look clear, but deep inside the power plant, a totally different kind of ice is building up, literally starving the engine of air and just waiting to cause a sudden power failure.
This really happens in two main ways. Impact icing is pretty much what it sounds like. Ice builds up and physically blocks the air intake. Simple. But carburetor icing, that one's much sneakier. It's that same pressure drop cooling thing we talked about with the wings, but now it's happening inside the engine's carburetor.
And this brings us to one of the biggest myths in all of aviation. You hear icing, you think winter, right? But carburetor icing can pop up on a beautiful, warm summer day. So, any guesses just how warm it can be outside for this to happen?
You heard that right. 30 degrees Celsius. That's a hot day. All you need is humidity over 50%, and that cooling effect inside the carb can plunge the temperature below freezing and start building ice. It's wild.
Okay, so with all these hidden dangers and weird, counterintuitive ways ice can form, how on earth do pilots actually defend themselves? Well, it's a mix of smart forecasting, super strict rules, and one absolute unbreakable command. Long before the wheels are up, Pilots are digging into a whole toolbox of weather info. They're checking forecasts for icing levels, they're on the lookout for major weather alerts, and they're decoding airport reports for any sign of freezing rain. But really, the absolute gold standard? PIREPs. These are real-time reports from other pilots who are up in the air, right there seeing it with their own eyes.
And here's the most important takeaway. The #1 defense against ice isn't some fancy tech on the plane. It's a decision. The golden rule is avoidance, period. You don't try to be a hero and fly through it. You run. You change altitude to find warmer air, or you just turn the plane around and go home.
And look, this isn't just some friendly advice, it is the law. In Canada, it's known as the clean aircraft concept, and the regulation on this is completely non-negotiable. The rule states, and there's no wiggle room here, that you cannot even think about taking off with any contamination on the plane.
So what exactly are these critical surfaces the law is talking about? Well, it's basically everything that makes the airplane fly. We're talking wings, propellers, the tail, the stabilizers. If it's a part that creates lift or controls the plane, it has to be 100% clean. No excuses, no exceptions.
Okay, but this brings us to one last, totally wild scenario. Imagine you've done everything right. The plane is perfectly clean, but then ice starts forming on the wings while you're sitting on the ground. And it's a warm day out. How is that even possible? It's this wild phenomenon called cold soaking. So an aircraft has been flying way up high, right? The fuel in its wings gets super chilled, way below zero. Then that plane lands somewhere warmer and more humid. Well, that freezing cold fuel turns the metal skin of the wing into a condensation machine. Moisture from the warm air hits that cold wing and freezes on contact. It creates this totally hidden layer of ice right when a pilot would least expect it. It's just one final reminder that in aviation, the enemy you can't see is almost always the most dangerous one.